Welcome back to Generative AI 101, the podcast where we dive into the mysterious and often entertaining world of AI and generative AI. I'm Emily Laird, your guide through this labyrinth of algorithms and data. Today we're exploring the thrilling, sometimes nerve-wracking domain of reinforcement learning. Imagine teaching a dog new tricks, but this dog has a thing for video games and complex problem solving. Ready? Let's get into it. Welcome to Generative AI 101. All right, let's talk reinforcement learning. Think of it as the rebellious teenager of the machine learning family. It's not content with just following instructions or finding patterns. No, it wants to learn through trial and error, just like we did when we first learned to ride a bike or throwing our first house party without getting caught. Some were more successful than others. So what is reinforcement learning? Reinforcement learning, or RL, is all about agents learning to make decisions by performing actions in an environment to maximize some notion of cumulative reward. The agent interacts with the environment, receives feedback in the form of rewards or penalties, and uses this feedback to learn and improve its future actions. It's like training a dog to fetch the newspaper. Give a treat when it does well, withhold the treat when it messes up. There are some key concepts of reinforcement learning, so let's cover those. Agent. So, the learner or decision maker. Think of it as the dog in our analogy earlier. Or better yet, a contestant on a game show trying to win the grand prize. Then there's environment, the world the agent interacts with. For our dog, it's the living room filled with obstacles. For a game show contestant, it's the set with its flashing lights and buzzing timers. Then we've got actions, the moves the agents can make. For the dog, it's fetching, sitting, or barking. For our contestant, it's answering questions, choosing lifelines, or making a strategic guess. Then we have rewards. The feedback the agent receives, positive rewards for good actions, treats for the dog, points for the contestant, and penalties for bad actions. No treat, points lost, or getting slimed. Policy. So the strategy the agent employs to decide which actions to take, it's the contestant's game plan, deciding when to play it safe and when to take risks. Let's look at some real-world examples to help this make sense. Self-driving cars are a great example of reinforcement learning. Think of self-driving cars as the agent. Its environment is the road, complete with other cars, pedestrians, and unpredictable cyclists. The actions are steering, accelerating, and braking. The rewards? Safely navigating to its destination without causing a pileup. Penalties? Getting honked at by annoyed drivers, or worse, causing an accident. What about video games? So reinforcement learning is like the ultimate gamer. Imagine training an AI to master a game like Atari's Breakout. The agent moves the paddle, actions, to hit the ball and break bricks, the environment. It earns points, rewards, for each brick it breaks and loses the game penalty if it lets the ball fall. The more it plays, the better it gets, just like a human player. Then we have robotics. So picture a robot learning to walk. Each movement of its legs, actions, affect its balance and progress, environment. It gets a pat on the back, reward, for staying upright and moving forward, and a virtual slap on the wrist, penalty, for falling down. Over time, it figures out how to walk without looking like a tipsy toddler, or you leaving the bar at 2 a.m., no judgment. Then there's marketing. Yes, even in the cutthroat world of marketing, reinforcement learning has its place. Think of an online recommendation system. The agent suggests products, that's the action, to customers browsing a website. You got it, environment. It gets a reward when a customer makes a purchase, and a penalty when the customer clicks away. Over time, it learns to recommend products you might actually want rather than those bizarre, completely off-base suggestions. Of course, it's not all fun and games. Reinforcement learning has its challenges. One biggie is the exploitation dilemma. So the agent has to decide whether to explore new actions to find even better rewards, right? So that's exploration. Or stick with what it knows well, which is exploitation. It's like deciding whether to try a new restaurant or just go back to your favorite pizza joint. We're all guilty of that, right? We're comfortable in what we know. Balancing these two is key to successful learning. Another challenge is the sheer amount of data and computation required. Training an agent through trial and error can be time-consuming and resource-intensive. It's like training for a marathon. You need to put in a lot of miles before you're ready for race day. In summary, reinforcement learning is a fascinating and powerful approach to machine learning that mirrors the way humans and animals learn from their environment. It's used in everything from gaming to robotics to self-driving cars, proving that sometimes making mistakes is, in fact, the best way to learn. Thanks for tuning into this episode of Generative AI 101. I hope you've enjoyed our dive into reinforcement learning and this mini-series on machine learning. So next we're going to move into deep learning. And if you have questions, thoughts, or just want to connect, find me on LinkedIn, Emily Laird, Laird. Let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about reinforcement learning now than you did when you arrived.